This here is what's called a bell curve or a normal distribution. Okay. Now, what a normal distribution stands for is the following. Okay. The things that are normally distributed are stuff like distributed. Okay. What's normally distributed is things like heights. Okay. You have the smallest people are really rare. Like people under 3 foot are really rare. If something's really rare, it's not too high. If something's more common, it's much higher at that height. And then eventually in the middle you're going to be reaching what's called the mode. The mode is the tip of the hill, so to speak, the top of the hill. This means that most people would have a height of, let's say, most men would have 177 centimeters. This means that the height of 177 centimeters. Okay, now in our question that I wrote down is I'm talking about IQs. IQs are normally distributed as well. So if you imagine we had all over Ireland at junior cert, okay, what we did was we basically set an exam, we got all the results of the exam, and then we calculated the mean and standard deviation of basically the of the set of data. Okay, so if you can imagine, okay, we did our tests. Sorry, excuse me, guys. So, guys, in this question here, okay, what we're doing is we're doing the mean IQ. And mean means in a normal distribution, the mean is dead center. It's 100, okay? Now, what this means is, you know what? Mu is the mean, okay? What this actually means is the mean. Okay, that's the mean, and the mean is 100. Sigma stands for the standard deviation, and the standard deviation is 10. It says it in the question. Now, all over the country, people will be putting in their results. They'll be getting 90, somebody will get 130, somebody will get 110, then you might somebody on 95. You average all them up by getting the mean, and then you know the mean of the country. And you then can put in a big computer or a big calculator and calculate the standard deviation. Now you might be saying, what good is that? Like, what does all this matter? Now it's all about finding out how many people are within certain ranges, okay? Now for instance, this score here is 100. Mu is 100. What is mu plus sigma then? 110. Mu is the mean. Mean plus standard deviation. So what's the mean plus twice the standard deviation? 120. And after that? 130. And finally this would be 90. What's this? 80 and 70. Now, what this means here is, okay, if I want to find out what range of IQs contain exactly 68%, the first empirical rule means that if I take one standard deviation away from the mean, and if I was to add on one standard deviation onto the mean, everything that's in between those two is 68%. That's the rule. You gotta learn off by heart. If you take all the scores from minus one deviation up to plus one deviation, you get 68% of the population should be within that score. If you did the same for height, and you said that you could find out that 68% of the population are in between, call it 5'7" and 6'1". Now, what would be even bigger again is the second add on 2 deviations. Okay, 2 deviations would be from 80 to anybody? 120. In between 80 and 120 contains how many people? 95% of the population are in between these two scores. Okay? And then finally the last one is, if I did it from 70 to 130? 70 to 130, anybody? 99.7. That's all the empirical rule is. It's actually relatively easy. Now, there's something else that you'll be doing later on, and let's say for instance you got a score of 110. If you got a score of 110 in an IQ test, how much of the population does that make you technically have a higher score than? So if you have 110, you're here. Okay? How much of the population have you scored better than? It's 34% to here. And what do you think it is from here to the end? The whole thing is 100%. So what do you think when it's split in half? 50. If you get an IQ of 110, you're smarter than, not smarter than, you score higher than 84% of the population. That's what this is used for. Shh. Yeah.
Graph affect the percentage, like the shape of the earth?
It's what's called normalised. They will normalise it. Even if there's slight deviations in it, they will say it should always turn out roughly normal every time, okay? So that's what's called bell curving. Sometimes testers have been known to do this, but if they don't get enough people passing, they said, I have to have 30% of the people passing every year. So they use what's called a bell curve to adjust the mark so they meet their target, so to speak. Okay?